If I reply first, I'll say yes. Okay, that should be good. That should be good. Okay, come. Yep. Same chemical properties, but gradually changing physical properties down the group. But I want you to highlight one more. They are defined by a specific functional group. Okay, keep that in mind. They are defined by a specific functional group. And I want you to add this. I haven't mentioned this before, but can you just add into your notes? Homologous series is they share. Okay, maybe I be more grammatically correct. The members share the same general formula. So take note of this word general formula because your exam question may ask you for the general formula. Okay, take the worksheet I've given you, this blank one. Let's start with the easiest group. Right, notice I've only given you 4 pieces rather than 6 pieces. Oh, because I still got another 2 pieces. I have 2 pieces I haven't given you yet. Okay, come. The first one, alkanes. As always, watch the spelling. Functional group. Do they have a defining functional group? For this one, no. Alkanes is very special. It has no functional group. But you have to recognize it because they contain only C and H with single bonds. Now, of course, the single bonds are all covalent bonds. I leave out to you whether you write that. General formula, you need to remember.
Sure. Is it everything under the series are covalent compounds?
Yes. There is one exception later on, but I'll tell you that when the time comes. Come, write down general formula CnH 2n plus 2. Which you need to remember. Oh, no way. So now look at the members. The n is an integer. So n starts with 1. For your syllabus, good news, you only need to know the first 4, 1, 2, 3, and 4. Bad enough. Once you see the pattern, then it's not too bad. So first one, methane. You've already seen it before. Formula. If I put n equals to 1, CH 2 times 1 plus 2, 4. Yeah, you sub into this formula here, sub n equals to 1. And you get CH4. Now, it's important to differentiate between these two formula and structure because the question can ask you for one or the other or both. Now, how to draw the structure? Like that. Okay, so check. I have 4 covalent bonds. 1, 2, 3, 4. Those 4 lines are covalent bonds. Quick reminder, carbon can form how many covalent bonds?
4.
Yes, right. Carbon should have 4 bonds. Therefore, you need to check your structure. Make sure you see 4 bonds there. Hydrogen, 静姐?
1.
Yes, only 1 bond. Okay, come. Next one, n equals to 2. You need to remember the name. Ethane. Oh, by the way, the naming is quite standardized. So if you see meth, if meth means or meth means 1 carbon. Ed means 2 carbons. It's quite standardized. Later you will notice it. Formula? See? Good, good. C2H6. Structure, I'll draw it for you for now. Okay, well, maybe you're a bit short on space, but try your best. No space. You can draw in your notebook.
No.
All single bonds, huh? Third one, name prop. A prop means 3 carbons. Fourth one, butane. So very simple, both of you write out the formula, draw the structure for both. So prop means 3 carbons, but means 4 carbons. Yeah, write out the formula. Use the general formula, please. Sub in n equals to 3, sub in n equals to 4. Right, not space. Cannot. Make sure you can draw it when the time comes. That's it. All right, so make sure they're correct. And Jingqian. Can follow. All right, stick. Good news, very easy to remember. All 4 are gases. But obviously there are many others down because when you go to, let's say, C10, C10 should be H how many? But once you reach this guy, it is a liquid. So keep this in mind. And if you go even further down, let's say C100, H2O2, that will be a solid at room temperature and pressure. So keep this in mind. Yeah? Only the first four are gases.
So meaning C5 is really liquid.
Yeah, actually C5 is a liquid. So I hope you can tell what to write next for MP and BP. Essentially, as you go downwards, MP and BP increase. Now, in case you want to ask why, okay. Remember what are the bonds? What are the bonds among them? Yes, covalent. However, there's something else, right? What other bonds are there in between them? In between molecules? Yes, good. IMF are the ones that affect MP and BP. So I want you to write down, basically, they get stronger. No need to know the reason, as for higher level. About solubility in water. I said that these are all covalent compounds. Are they soluble in water?
Yes.
Okay, no. That should be easy to remember. Density, as you go further down. Actually, you should be able to figure out. I did say that they turn from gases to liquid to solid. So, yep, increases. Of course, the molecules become bigger. The MR becomes bigger. I think that one is obvious to you. Now, lastly, they are covalent compounds. No ions, no free electrons. So this one should be quite straightforward. No electrical conductivity. Jingjie, write that down too. Oh, you wrote already. So alkanes are the simplest organic compounds. Okay, tell you. Instead, they will likely ask the reactions. Okay, good news. Only 3 reactions to know, or 3 chemical properties. Okay, first one, combustion. Now, it's very simple. Combustion is burning. So, okay, you need oxygen to combust. What are the products? Okay, you better know this. Complete combustion means you get CO2 and water. Okay, let's give you an example. Propane C3H8. O2, HCO2 plus water. Okay, guys, balance the equation. Free way. Okay, good. Free CO2. What's next? Four. Okay. O2. O2? Two. Is it? Are you sure it's 2O2? Three? So you don't think can follow the balancing? So how many O2 do I need? Come. Look at O. How many on the left? Two. How many on the right? No. 3 times 2, 6. 4 times 1, 4. So they are 10 on the right. I hope you don't be.
5.
Yes. Left side times 5. Don't be careless because this is likely to come up. Oh, by the way, state symbols, I hope you know. Propane, say that. State symbol. Yes, we mentioned that. O2.
Yes.
CO2.
Yes.
Good. Water. Yep. 10. 10. All right, I'm going to erase this. Now, just a few more things, conditions and comments. Can you add in combustion is always exothermic? And the way I wrote the products, CO2 and water, I assume complete combustion. Remember, I used that term earlier. Only then you get CO2 and water. If you get something else or you get something more, then it's not complete combustion really.
So you mean if it's not complete combustion, there will be another part?
Yeah, and since you asked, let's write it down too. Because it comes up in the last chapter. So if you ever get incomplete combustion, you will get CO. Look up for that in your question. You may still get CO2, but you will get CO and or carbon. As products. Jingjie, this one CO and or carbon may be formed as products if there's incomplete combustion.
So if it's in plus O2, you get CO2 minus H2O, CO.
Yes, possible. You get some CO2, you get some CO. So look up for that in your question. If CO ever is produced, it means incomplete combustion. Okay, can you add in one more thing up there, which is quite important? Now, basically, I didn't add in here because this one is a, okay, tell you what, let's write it below. Let's write it down here. Now, as you go down the series, it becomes harder to burn. down the series. Let me use the term combustibility. Come, tell me. So, which member is the easiest to burn? Yes. Okay. Take note, is the easiest to burn. So I won't go further about that. Oh, just a combustibility is a bit gray because it's about combustion. It's rather than physical property. What is it? It should be a chemical property, but outside in the real world, some people call it physical property. Especially people who don't know chemistry. Okay, let's go on. Right, next one, next reaction. It's called substitution. High chance of coming out. Okay, let me just double check now. What? Because there are many substitution reactions. Let me see which one is your syllabus. There's only one which is in your syllabus. Let me see. Yours is what? Yours is chlorination only. Okay, come. Yours, for you guys, you're only interested in chlorine. Okay, there are many kinds of substitution. So for you guys, it's only chlorination. Later you see very soon. Okay, so basically it works like this. Okay, plus chlorine. And you get chloroalkane plus HCl. Okay, let's look at the simplest one, this one. Come, try to follow. This chlorine is going to break up. So what happens is one chlorine will bond to carbon. So do you realize what has happened? This hydrogen is substituted with chlorine. That is why we call this substitution. Can you? Yep.
Let's say it's ended. Only one hydrogen gets substituted.
Unfortunately not, because the story hasn't ended. But let me answer your question. One hydrogen will get substituted first. Any hydrogen.
And
It can be anywhere.
Also, this one also can be any hydrogen.
Yes, it can be anywhere. So you can substitute any of the form, it doesn't matter. You still get it right. However, okay, I'm still writing. Okay, there's one important thing about conditions. For this reaction to run, you need sunlight. Or UV light. So just keep this point in mind. It may or may not come out. But let me just, to make things complicated, this may not be the end because look at this guy here. I'm not going to elaborate too much because this may not come out. So this guy is from here. And what happens is, if I have some more Cl2, you know what will happen? Yes, I will substitute a second time. Yeah, then end of story, then it stops. It's possible. Okay, it may substitute again, as long as you have some remaining Cl2. Oh, of course, you still need sunlight and UV. Yeah. UV ray can be artificial, can be natural, it doesn't matter.
What?
This for what? This one is used as a solvent. Yeah. I think I didn't mention it, but once it gets substituted, this becomes a liquid already. But you don't have to know that. Okay, so that's all I want to say. May or may not come out. Good news, only 3 reactions, the last one, which is the one most likely to come out. And the most difficult one. No titration. Okay, but before I go further, any questions about these two reactions? No. Okay, last one. Almost 90% is going to come out because it's the most difficult one. The name is called cracking. Crack. Ammonia, they don't use the term cracking though. It's quite a heavy process, man.
No, like, because the technical is some cracking one. So,
Into what? Never mind. Okay, guys. Unfortunately, 2 types. One is called thermal. One is called catalytic. Okay, 2 types of cracking. Now, the difference is this. For thermal, you need very high temperature. But no catalyst. Hopefully, you remember what catalyst is. What does it do? Good. But for catalytic, you don't need such a high temperature. But a catalyst is present. Yeah, very high. Okay, actually, I won't say it's fantastically high. Very high means about, let's say, 600. High is about 300, 400. 1,000 is extremely high. This one is the worst one because there are many possibilities. But in general, you will have this. You have an alkane. Now, whether thermal or catalytic, the reaction is the same. First possibility, alkane, remember this about alkane, is going to crack. Crack means break into small fragments. So you form one alkane. Let me repeat, or let me rephrase, you form a smaller alkane plus one or more alkenes. Later I'll give you one example.
This is thermal.
Either one can be either. The reaction will be the same. Or can be thermal or catalytic as well. You will start with the same alkane. And you crack it into one or more alkenes. Watch your spelling. Plus just one hydrogen.
So both is for thermal and catalytic.
Yeah. Either thermal or catalytic can engage in either reaction. Oh, by the way, can you add in? This process is used in the production of hydrogen. This one,
Yeah.
cracking. That's how you get hydrogen. You need hydrogen to make ammonia. Zayden, you do remember that this can be used for the production of hydrogen. Of course, it doesn't come out all the time. I'll give you one example because, as I said, this will likely come up. Okay, so let's say I have this. It's cracking. I have this guy. Okay, what's the name? Yeah, but the specific name? How many carbons are there? Yes, butane. All right, so I crack it. All right, I would get this H2 plus this. This is just an example. There are many examples. You must be able to figure it out. And what do you notice? I have double bond. I have double bond. So once you see a double bond like this, these two guys are called alkenes. These two are known as alkenes. So basically, for this butane, it cracks over here. Count how many carbons on the left, how many on the right? Four. But more importantly, count the hydrogen. Is it the correct number? Zayden, you do try. How many carbons on the left? How many on the right? It should be the same. It should be because you may be asked to do this in your exam. I hope you counted correctly. 10 hydrogen here, 10 on the right. Okay, but that may not be all. I can give you this example too. Same reactants. What if I crack here? Actually, you can't control one, by the way. In real life, you can't really control. It's quite random. I mean, to a certain extent. So what will I get? I get 1 carbon. And I get 3 carbons here. Again, same thing, count. Make sure the hydrogen and carbons are the same number on both sides. Same, right? I hope you can convince yourself, total 4 carbons, 10 hydrogens. Correct? And you notice what is this guy here? It's methane, huh? So this is an alkane. But this guy has a double bond, so this is an alkene. Do these two examples fit my rule?
Yes.
Yes, it does, huh? Hydrogen plus alkenes, alkane plus alkene. Okay. But you know what's the problem? In the exam, they may not give you this 4 carbons. They give you 6 carbons. And then they give you MCQ. Which are the possible products? A, B, C, or D? Draw. You may need to draw, but the best way to solve it is to count carbon and hydrogen. You need to count both. You need to count both.
Count. So you need to draw and count. Or they just
Okay, because you know how they will tell you.
No.
Imagine, I mean, it takes some calculation to set a good question, but I'll try to come up with one. So imagine they tell you this, I have this alkane. They don't even draw for you. You have to draw yourself. And then they ask you, you crack it. What are the possible products? A, okay, or B,
A.
Just 2 choices here, no need to think too much. When you crack this guy, which is the correct answer?
A.
Yeah, I hope you counted 6 carbons, 14 hydrogen. So they count both carbons and hydrogen. So answer is A.
So you basically just match.
Yes. Okay, it's likely to come up. Very likely. Okay, let's go on. Oh, any questions? No. Yeah, that's okay. Oh, one more thing. Especially for you. New rule, no, it's an old rule. Okay, Zayden, you can sit back on this one. For him, it's called isomerism.
Hell.
Luckily not. But it can be just as bad. Only for you.
So is it number 3?
It's not a reaction. It's a concept. So let's say I have this, let's say C4H10. How did you draw the structure just now? Did you draw?
No.
You didn't?
That's
Oh, okay, not too bad. At least there's something there. Now, what if I draw it this way? Can you check the number? Is it still the same formula? Is it still C4H10? It should be. Right. Yep. But what you need to know is they are different, no? Structurally. Okay, I'm not going to draw the hydrogens, but make sure you know hydrogens are there. These two are they have the same formula, but different structure. So I want you to write this down. Means compounds with the same molecular formula, but different structure or different structural formula.
That's it.
But the question is going to be can be very complicated, no? Imagine, they'll give you this stupid question here. They'll tell you, C6, well, you're going to have fun with this. C6H14, how many different structures can you draw with the same formula?
Oh, okay.
Then you're going to have real fun, man.
Good.
Not many, just about a handful.
I mean, too many.
But anyway, I don't need you to draw now unless you want to draw for fun. No, it can be structure quicker. They'll ask you to draw.
Oh, no time.
No time, then you won't get the marks. But can be MCQ also.
Usually how many?
You mean how many questions? Maybe.
Oh. You know, when I ask this, how many you need to draw?
Maybe 3.
Oh, then 3.
3 or 4. Yeah.
Okay.
Oh, okay. Come, Zayden, come back. Now, just take note about the structure. Let's say I have this thing here. I can actually look carefully. I can draw like this. I'm not going to draw the hydrogen, but make sure you know that they're there. So I will draw it like this. Can I draw like this? Yeah. Yeah, Zayden, this applies to you too. Can I draw like this?
Yeah.
No, the answer is yes, because they are still the same. The point is, look for the connection. 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6. It's still 6 in a continuous line. Oh, I mean, at least a continuous pattern. So I can, if you want to have fun, you can even draw like this.
No fun.
No fun. As long as the bonds are still similar, the atoms are still the same.
Got too many places.
So recognize these three patterns are exactly the same. Huh? 1, 2, 3, 4, 5, 6. Okay, so be open-minded, especially for you. Yeah, but you still have to recognize them. Can't say that. Now, likewise, Jingjie come back here around. Look at this. How did I draw just now? These two guys. I drew diagonal, but they need not be diagonal. It can be like that. Oh, yeah, it looks better. I can draw like this, no? I can draw like this, no? They are all the same. So please be open-minded, really serious, especially for you. The last chapter on polymers, they have all sorts of patterns. Just study how. Yes, as always. Can say that. That means the angle doesn't matter. It can be up, down, left, right. Can say that. Yeah. Okay, let me see. Do I have anything for you to do? But there are some questions that you cannot do it. But I don't want to overwhelm you today also. Okay, let me just print these few pages for you to try out. I cannot find a seat. I cannot find I cannot find just give me a moment.
Try test for gas, right? It doesn't work on
Which gas were you testing?
carbon dioxide. No, carbon dioxide is oxygen and hydrogen. Ammonia also. They always every time I try, it doesn't work.
You mean you don't hear the pop sound?
No pop reason. For once, there only pop. I don't know why it doesn't work.
Maybe you were too slow.
Oxygen.
Yeah. Maybe you were too slow. You must get ready your that what do you call that? Yeah, the stick. Like that's the spin. Yeah, you have to get the spin ready, stand by already.
So before you, however, you need to get ready.
If you can.
I have to take the test and put it at my nose.
But
to smell it.
So do you manage to smell it?
It smells weird. So
Smells weird. Yeah, it smells like pee, that's all.
my eyes water.
Yeah, ammonia is terrible. Terrible.
Weeks.
Is it? Oh, next week. Yeah, so try to treasure your secondary school days.
What's that? Treasure.
Very fast it'll be gone. Or maybe you're happy for that.
I don't know. It's a primary school.
It's like primary school.
Like the last year, like P6 months.
Yeah, kind of. Then you want to decide where you want to go next already.
Then you go west.
That's what you said. Decide which obviously it's probably the one to play games. Yeah. You are probably the one who
you might get desperate.
Oh, the pay is good. But you have to work on weekends.
Oh, like
Okay, you can't very easily through force MCQ. Awesome.
but that the chase things right. Like 1.8, right? It's like a O-level bios.
Yeah. Right. Yeah. Please, no joke, no joke. Oh, guys, can you go back to your notes? I forgot one important thing. There's one more thing I need to cover. Just go back to your notes. This is a simple thing, but it may come up. Okay, there are two words you need to know. Or actually more than two words. Saturated and unsaturated. You can write it down first if you want to. So, where was my here, right? Okay, just do words saturated and unsaturated. Okay, Zayden, jot down too because this can come up and you try to get the marks for this. Now, very, very simple. Unsaturated compound means at least one C double bond C in the structure. Yeah, alkene is a saturated compound. I mean unsaturated compound. Saturated is most obviously is the reverse. That means basically all single covalent bonds. What if
unsaturated.
What about that?
It's always down on.
For O levels, you take it as a lesson. Okay. Right, so of course the best example is alkane. Alkane is a saturated compound. For unsaturated, it would be alkene. Okay, one example I want to mention is a bit, what was that? Okay. One example in daily life for unsaturated compound is vegetable oils. Now, for saturated compound, in daily life, one example is fats. So there's a difference between oil and fats. And okay, this one I won't mention first, maybe next time. But just take note of these two words for now. Actually, there's one more word. It's a continuation. Zayden, right now too. Based on unsaturated, they can add the word poly in front. What does that mean? It means you have two or more C double bonds. So just keep that in mind. The word poly may or may not come out. Okay, so guys, try out that worksheet. It's only true or false in MCQ, so it should be quite easy. Okay, that one I haven't gone through yet. You can skip some of those. Okay, I'll list down those you need to do today. A, you need to do. Zayden, you can eliminate B. It's not in your syllabus. But Jinjie, this is in your syllabus.
What?
Okay, both of you try C as well, even though I haven't mentioned viscosity. Oh, okay. For today, I marked down those with a blue dot that you need to do. But for you, you skip B as well. A, C, G, I. Yeah, for now. Okay, for MCQ, let me take a look which one you need to fill out. For today, Jie, you need to do this. Jaden, for MCQ number 1, you can skip. This one. You can skip this one. This is not in your syllabus. You do number 2. Do number 3. Do number 6. I think you better try number 6. Just remember, this is one of the questions you would expect to find about cracking. Okay, then you try number 6.
Do everything as well.
And question 4, 5.
8 is 7.
Yes. 7 is for Jie only.
The true or false is
A, C, G, and I. Actually, Jie can skip this one for today because I haven't mentioned butane yet. Jie can skip for today. Okay, come. This one, right? Which question again? 1. Now remember, Jie, this one is especially for you, right? Where is my isomerism? Just now I drew isomers for butane, right? You draw that down. Yeah. Yeah. But well, I was going to write something, but never mind, you just follow. Okay, come, Jie, look carefully. This one is obvious. 1, 2, 2, 2, 2, 3, 3, 2, 4. So this is what we call straight chain. Straight chain, which you may want to take now somewhere. So straight chain. But look at this one on the left. Do you notice I go from 1 to 2? But at point number 2, I can either go down or I can go right. There is a branch. So this is what we call branch chain. I need to check the question. Let's go back. Number 1, right? You see?
Yeah.
Which of the following statements is true? Which answer do you say it is? B. S is a branch chain alkane. No, this is a trick question because you look carefully. I go from 1 to 2, 2 to 3, 3 to 4. There's no branching. Don't get tricked.
No, you can. Right, H2.
Oh, okay, can.
Let's see, right?
Then I learn along the way.
That is, I mean, that is A.
Yeah. Yeah, good. Hey, Zayden, done already. MCQs also done. Oh, that's okay, that's fine. Okay. Tintin, are you done?
No.
No, huh? Okay, never mind then. We'll wait for you.
Very nice. Then walking forward, then on this one, then walking forward. Then they go back kind of questions. After answer the question.
And then, okay.
Please check your favor.
I understand.
Thank you.
Okay.
Do you all want extra questions to practice optional one?
Because,
But if you all want, I can say.
because exam paper goes level.
Or you have
Addition.
exam equals to do.
Addition, oh, we can skip the addition.
Revision. Exam paper. Yeah. Just get your quick answer.
Is it okay?
Worksheet becomes
If you all can answer, cannot understand for what we did, something like sketch and chat or even field.
okay. So, starts at my ear.
Oh, writing is minus 2b squared over the discussion. For the reaction, you probably didn't get answer.
Okay. Right. Experimentally. Then. Pointing.
I still like a picture if I don't know. Right, because how do you for next videos?
Yes.
No,
And then.
it's the power, right?
This is
B squared, this is C squared.
yeah.
Because each one. Sorry, two. I think you asked me to man, right? You know, cause you don't want to. Oh, C cube of different, right?
Oh,
C cube squared, you don't want to.
see.
Okay. Okay, come, let's quickly go through. A, true or false? Well, it's actually false because you forgot something. This is a trick question. Carbon, hydrogen, single covalent bonds. That means they only have C and H bonds. Not true, right? Because they also have C single bond C. So it's not mentioned in the question. They also have CC single bonds, not just CH. Tricky. Okay, I didn't mention viscosity, but I will mention this again. But viscosity is how well a liquid flow. That means the more viscous it is, the harder it is to flow. So anyway, for C is true. Remember, as the molecular size increases, your boiling point increases, melting point increases, but what was that I said just now? What else? Density also increases. Therefore, it becomes harder and harder to flow. So viscosity increases too. G? Actually, I don't like the way it's structured because of the English. Actually, what they're saying is this. You produce alkane plus alkene and alkane plus hydrogen. That's what the question is saying. Do you produce this combination in cracking alkane plus alkene, alkane plus hydrogen? No, it should be alkene plus hydrogen and alkane plus alkene. I mean, it's still the way the English is structured, which I don't particularly like. So it's false. Last one, right? False, because I really stress on the word poly. Poly means two or more. It's not one or more. Okay, it's tricky. But luckily, true or false doesn't come up in your O levels. Okay, MCQ. Number 2. D. Sorry. D. First thing first, do you recognize this formula is an alkane? Yes, good. Is it soluble in water? No. Is it a gas? No. Only the first 4 are gases. But how about alkane? Is alkane hexane and alkane? Yeah, it is. So remember, they are in the same homologous series, so they have the same chemical properties. Yes, it's C.
Oh shit.
Oh, I didn't mention that point about complete combustion. Complete combustion also means there is excess oxygen. If you want to write down your notes, complete combustion means excess oxygen. Well, you learn along the way. How about 3? Is it addition reaction? Well, I didn't mention addition. All right, so obviously not.
Oh, okay.
What reaction is that? Isn't this a substitution?
Yeah.
Okay, it's a substitution. Make sure you can see. Is Q hydrogen chloride? Yeah, of course. In the presence of sunlight? Yeah, I did say that. So you should know the answer by now. Good. 4, okay, 4 is not here. Anything else? 6. Yeah. Come. There's something that you have been careless. C6. How can you crack C6 and get something bigger? You can't. What's the meaning of cracking? You make it into smaller fragments. How can you join them together to become bigger? You can't. Don't be careless. So D is obviously the answer. Okay, for you, Jingjie, do you try 7? 2.
Oh,
Oh, you didn't?
it's 8.
A.
Okay.
1 and 3. Okay. So 2 is up. Oh, Zayden, you can go ahead first. How many? Okay. How many carbons are there? 1, 2, 3, 4, 5, right? How many hydrogens? To be 12. If you count correctly,
Yeah.
it's 12. Okay. But the thing is this. How come 2 is not counted? Okay. It's not just counting it. There's something else. What?
Bye, teacher.
Okay, bye. Let's highlight. 1, 2, 2, 2 to 3, 3 to 4. And there's a branch here. Good. At the 2 position. So look at number 2. I count from the right. 1, 2, 2, 2, 2, 3, 2, 3 to 4, and I branch at the 2nd position as well. So therefore, these two are exactly the same.
What?
They are not isomers, they are the same thing. Tricky, right? But it will come up for you. It will. Okay. All right. I'll see you tomorrow. Yeah. EMI. Have you finished EMI? Oh, I still got a bit left.
You went through transformer.
Yeah, but have you done the exercises on transformers? Not yet, right? I don't think so. Okay.
Check the problem actually.
Yeah, correct.
Yeah. Just learn here.
Huh? Oh, yeah. Are you sure?
They jump around.
Oh, they jump around.
Yeah.
Yes.
Bye.
Okay, that's all for today.
Bye.
Bye.